So Materium is a pellet extruder that can be installed plug and play to your Ender 3 V3 SE, or it can also be installed in your open source 3D printers. Materium is not just an extruder for a 3D printer, it can also make filament. In this video, I'm going to try to demonstrate that and compare what it's like to directly print with Materium versus a filament made with Materium printed on a other 3D printer. For the direct printing with Materium, I will be using my own printer. You can also install Materium on a Voron or any printer that you design that you can wire. And for the FDM, I'm going to use Bambu A1 from Bambu Lab with a 0.4 nozzle installed. The material I'm going to be using is PLA pellets and PHA powders derived from seaweed. With this, that's pretty high. So after that first trial with pure powder being fed into Materium, the problem is that the powder flows back up and it does not form a melt plug. A melt plug is a phenomenon in pellet extrusion which is used to form pressure to push material out of the nozzle. So this area here is cold and this is hot. The first part of the screw transports and push the material downward. At the transition zone forms something we call a melt plug, and this melt plug pushes the actual melt at the tip out of the nozzle. And the problem is with powder, it can flow back up at any point in the barrel. We call this a barrel. So what we're gonna do is we're gonna add PLA pellets. That is why we use both of these in the first place, because the pellet acts as an extrusion aid. The screw will be able to push the pellets alongside with the powder mixed inside, and we're gonna be using this glass to make the mixture. I'm gonna start with putting the powder in a glass and pouring the pellets inside and mixing it with a spoon, and also spoon feeding it into the extruder to avoid any contamination to the feed tube by powder, which is really a pain to clean. And then extrude it beautifully. So we're gonna start with printing a 2x2x2 centimeters XYZ calibration cube, and later a 3D Benchy. And then I'm gonna start making the filament by pulling it with my bare hands. This is not ideal by any means, but it will produce a printable filament in the end. As you can see, the insides are quite dirty with powder and pellets, but this can be cleaned later. And this is the filament resulted. My arms are already pretty tired from holding the filament, and I'm just going to directly feed it into the Bambu A1. It prints nicely, but I had to override the temperature because it was too hot for PHA. And this is the result. As you can see, that the bands and the print are caused by variations in the diameter of the filament. But as for the directly 3D printed, it's also not very good. Well, it's certainly not comparable to standard filament. But for the 3D Benchy, the filament just ran out, and I decided to continue with a black filament, and the bamboo just clogged. So I gave up. And this is to compare it with the directly printed. And as you can see, they are quite contrasting in quality and retractions and bridgings and in cooling. But the filament printed one is obviously looking better than the directly printed. But I'm not trying to compete with FDM filament in any way. So that was the comparison. Do you guys think it was fair? I apologize for the awkward language that I used in place of the technical jargons, but feel free to ask in the comments.